So let's look at what we've created. There's our input file, and now what's appeared is an output file, and you can see it's bigger, which looks good, bigger than the input file. So if we open file, and we seem to have had some sort of success, because here's 0, 0, 0. We're splitting up the samples in this case by 0, and we did that relatively quickly using the computer program. So what we want to do now is see what, or listen, and see what that's changed, how that has changed the original sine wave. So we can use gold wave again to open the file. There's the output file, which is what we've changed. So looks much the same, got that resolution. Let's listen to it. So we've lowered the note of the sine wave by putting the zeros in. How and why we might need to explore a bit. So let's just look at one of the sine waves, and now we can see how our program has put 0 in between each sample, so we can see now the samples are stepped up. Here's our sine wave. It's effectively widened it, which is why it sounds lower, because it's put all these spaces in, and now each sample stands out, though we can't hear each sample as of yet because the spacing is tiny. That represents each sample, remember, 44,100 times a second, so that's insufficient in there for us to actually hear the individual sample. Okay, so let's go back again. So if we go back into our program, this little thing here is a loop, so we were just adding 1 0. So if we change that to say a 3, we'll add 3 zeros. We missed out 2, but so we'll have 3 zeros in between each sample. Again, run the program, and again have a look at the result. And we can see we've added 3 zeros between each sample. You might have noticed now that the output file is getting very much bigger than the input file, and what I will do from time to time is to shorten the input file as we add more and more. But let's have a listen to what we've created. Gold wave. We open our output file and playback. Seemingly silence. We'll just raise the volume. So we're going lower in tone. Now, in this little exploration, the obvious thing to do is to sort of think, well, it seems that as we add more zeros, the tone goes lower. So we'll just carry on and see if that's true. So let's go back to our program, and we'll change the number of zeros to 10. And let's go back. So let's see what sine wave sounds like now. Which is interesting because we weren't expecting that. Perhaps we seem to have got a high pitch sound now, and a sort of buzzing sound as well. If we can have a look at our sine wave at this resolution, it looks normal. Going a little bit further, we're now seeing these spikes. Each one of these is a sample, and the gap between now is getting larger, which might be accounting for why we're getting this new sound, this higher pitch sound. Now remember, we're only adding zeros, we're not changing the sine file in any other way, and we're doing that to separate out the samples. That's what this very simple deconstruction consists of. So let's continue. Let's go for 100 now, see what happens. Now there it goes. Now we're adding a lot more samples to the file. So again, we're now getting a very large output file. So we will need to shorten our input file because we're adding lots more of nothing to it. But let's hear what we get with the gap now at 100. Goldwave took a little bit of time to load that as well because the file's getting bigger and bigger. So something sounds like it's pulsing, and this is the whole point of this. If we call it, I call it deconstruction, that things are emerging and disappearing as we progressively move more and more space into the samples. Here we can see now each of the samples is a straight line tracing out a sine wave, but this actual sine wave now is far too low a frequency for us to hear. In fact, it will become something else, which is quite interesting. Go back to our program.